So this is 1432, and we're given the setup with this block that travels in this groove here, and we're given that the spring is unstretched initially at A, but the spring is attached to the block, permanently attached to the block, and we're given the spring constant of 100 newtons per meter. The block has a mass of 0.8 kilograms, and what we're looking to find is F here. So once it travels 0.15 meters upwards to state B, the velocity is 2.5 meters per second. So that's what we're looking to find. So we're going to use the conservation of energy to talk about this. It initially starts from rest. So we know the kinetic energy at state A is 0. So let's solve this. So if we want the work term of F, we really need to know how far F is being applied in terms of distance if we want to do force times distance here. Well, we can figure that out by how much this cable length changes from A to B here. So at point A, the length of A here, which we'll just call from LAC, A to C here, we have 0.3 here, we have 0.4 here, and so this is a 3, 4, 5 triangle. So LAC is 0.5 meters. Okay, so let's analyze then at state B. So BC is what we're looking for, this length here. So if we draw out that triangle, this is 0.3, still this distance, and then this over here is 0.4 minus SB, which is 0.15, and LBC is the hypotenuse here. And using the Pythagorean theorem, we get LBC is equal to 0.3905 meters. All right. So if we're looking for the work term, we're going to be wanting to see what the change in these lengths will be. And that's going to be LAC minus LBC, which is 0.5 minus 0.3905. Okay. All right. Now, talking about other work terms, if we take a look at this block A, and if its spring is unstretched here, at time B, or at state B, we're going to have work terms based on, the spring. So we have the force due to the spring downward, and then we also have the work term related to the weight of the object as well. So let's write out our conservation of energy. The kinetic energy at A plus the work being done from A to B, the sum of the work being done equals the kinetic energy at B. And we know this is from rest, so this term is 0. The work terms, we have F, which we're trying to find, times this delta L, which we just worked out up here. And then we have the spring, and if you remember, the spring is 1/2 kx squared. And the reason it's negative is because at B here, the force due to the spring is actually downward and the movement is upward. So the movement is opposite of the force here. So we get a negative work term through that. So that's 1/2 kx squared, where k is 100 newtons per meter, and then x is SB, which is 0.15 meters. And then we have the work being done by the weight of the object, which is mg times the distance that it moves, which is just SB. So that's 1.15, where m is the mass of the block, 0.8, and g, as always, is 9.81. All right, and then the right-hand side of the equation, I'm going to erase this over here. The right-hand side of the equation is the kinetic energy 1/2 times the mass times the velocity of B squared. The mass is 0.8 kilograms. The velocity at state B is given in the problem as 2.5 meters per second. So we have delta L, 0.5 minus 0.3905. And then we have all the other terms solved for. All we need to do is solve for F, and F comes out to be 43.9 newtons. And that is the answer to 1432.